This is lesson 4.4. Apply the law of cosines in side, 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 and side angle side triangles. If you can, use the law of sines, but if the law of sines doesn't have the parts necessary, then the law of cosines is the way that you'll have to go. Let's look at this first one and I'll show you what I mean. In this triangle, C is 43.2 centimeters, B is 41.1 centimeters, and A is, oh, I've got the sides mixed up, just a second. I was doing them according to the angles. Let's do it this way. C is 43.2, B is 41.1, and A is 32.3. If you tried to set that up with the law of sines, you would have just the numerators, 32.3, 41.1, and 43.2. So you couldn't figure out what was missing in those. Let's look at using the law of cosines, and I'll show you how you'd go about doing it. Find angle A. Well, the cosine, I'm sorry, let's do it the other way around. I'm going to change colors here. A equals the square root of B squared plus C squared minus 2BC cosine A. Now the way the law of cosines works is that you can always tell what part you're looking for because these two letters are going to match. And then you add the other two. So, we know that A is 32.3, so that is the square root of 41.1 squared plus 43.2 squared minus 2 times 41.1 times 43.2 times the cosine of A. So when you square both sides, you get 32.3 squared, and then move this to the other side, subtract 41.1 squared, and move this to the other side, subtract 43.2 squared. And then if you, this part here is all going to be in the denominator, so it's going to be divided by negative 2 times 41.1 times 43.2. That will be the cosine of A. So if we take the cosine negative 1 of all of this stuff, we will get what A is. So that's one advantage of having our calculator, is that it certainly makes this look a whole lot easier. Let's write out the fraction, and we'll have 32.3 squared minus 41.1 squared minus 43.2 squared, and the denominator is negative 2 times 41.1 times 43.2, and I think we can close the parentheses, and we get 44.825 degrees, which should be rounded to the nearest degree as 45. There's two more triangles that you might want to learn how to use the law of sines for, or I'm sorry, law of cosines for. Let's look at them here. Okay, so we've got A is 55.3, B is 71.6, and angle C is 75 degrees. This is a side angle side triangle, and we're looking for angle A. What we can do with this situation, I pressed a button I shouldn't have pressed. What we can do with this situation is to find out what side C is, and then use the law of sines to determine what angle A is. So over sine A, 55.3 over sine 75. This is what we're going to use later on, but first we're going to have to find out what side C is. C is the square root of A squared, 55.3 squared, plus B squared, 71.6 squared, minus 2 times A, which is 55.3, times B, which is 71.6, times the cosine of C, which is 75. So on our calculator, it's nice to have a calculator that can put that all in one calculation. Square root 55.3 squared plus 71.6 squared minus 2 times 55.3 times 71.6 times cosine of a 75, is 78.3. So that tells us that C is 78.326. So now, since we're looking for angle A, the sine -1 of cross multiply 55.3 times sine 75 divided by 78.326 is A. So on our calculator, shift sign, we're looking for an angle, fraction, 55.3 times sine 75 over our answer from the previous question is 42.99, which would be 43 degrees. We can also use it to find the third side, which is probably the easiest application of the law of cosines, because it's just the formula exactly the way it's written. C will equal square root A squared, 32.3 squared, plus B squared, which is, plus B squared, which is 24.1 squared, minus 2 times A times B times cosine 100. So on our calculator, square root 32.3 squared plus 24.1 squared minus 2 times 32.3 times 24.1 times cosine 100 is 43.5 degrees. Oh, I'm sorry, 43.5 centimeters long. This is lesson 4.4, part D.